Welcome to Mission APSC AE YouTube channel. আজি আপোনালোকৰ কাৰণে লৈ আহিছো strength of materials ৰ এটা নতুন ভিডিও strength of materials ৰ Hooke's law যেটো ল হয় এই লটোৰ ওপৰত আজি আমি ডিসকাস কৰিম এই ভিডিওটো যিসকল APSC এসিস্ট্যান্ট ইঞ্জিনিয়াৰ জুনিয়ৰ ইঞ্জিনিয়াৰ নাইবা SSC JEE বা গেট এক্সামৰ প্ৰিপাৰেচন কৰি আছে তেওঁলোকৰ কাৰণে বেনিফিচিয়েল হ'ব সো Hooke's law কৈছিলে stress is directly proportional to strain but tate eta condition koisile stress is directly proportional to strain within the proportional limit so jodi Hooke's law statement to likhiba khoja stress is directly proportional to strain Hooke's law koisile but logote mention koisile up to proportional limit so बहुत बार examot question hodise Hooke's law is valid up to which limit so our answer is proportional limit if you try to draw this statement in graphical manner then we can say if we put in x-axis and in y-axis in x-axis suppose we are putting stress and in x-axis we are putting strain so ami strain to y-axis ot put no koru x-axis ot put koru because body eta jetia force lagibo first the body will generate some strain there is a change of dimension that's why we can say stress is a function of strain if we denote strain as epsilon so that means strain jeto stress or function hoy that's why we are putting strain in x direction and stress in y direction so according to Hooke's law up to proportional limit suppose a is the maximum point or maximum limit or the border of proportional limit then a2 hoise proportional limit then suppose this angle is theta and suppose it is origin according to Hooke's law normal stress that is sigma this one is proportional to normal strain so I can write it sigma is proportional to strain if we denoted this symbol then we can remove e kami jodi remove koru ki hobo modulus of rigidity into strain so ultimately this is the formula for Hooke's law so exam ot hode Hooke's law kuntu point leke valid hoy that is proportional limit so proportional limit means stress or strain or jitu ratio that ratio is constant that means if stresses increases suppose I am taking stress as 1 kilonewton per meter square and strain is suppose 2 in the next condition if the stress is increased as 3 strain is increased as 6 in the next suppose stress is increases you can say 4 and strain is increases at 8 so in every term you have seen the ratio is half right 1/2 is half 3/6 is if you cancel out then we will get half similarly if you cancel out 4 to 8 so we will get half that means stress although stress is increases although strain is increases but their ratio remains constant that's why this limit jitu limit like a ratio to constant thake hetu kwa hoy proportional limit and after that the graph will shape something like that is elastic limit so point b to is elastic limit so point b like body eta nijor strain to jetia tar external load to eri dia hoy si original position leke ahibo pare so he kane point B leke ami elastic limit kau ba point B to ami elastic point B liko aru from O to B we have called as elasticity or you can say elastic limit aru O pura A leke ami kau proportional limit. So Hooke's law only valid for proportional limit, not for elastic limit. So elastic limit hua hole that there is a non-linear relationship. Okay, so that is about Hooke's law. Then this E is known as modulus of rigidity, or we can say it is Young modulus. So in exam various time they ask about the definition of Young modulus. So Young modulus is nothing but normal stress divided by normal strain. How? Because as per Hooke's law, sigma is E into this strain, right? So E is equal to, we can say, normal stress divided by normal strain. So that is the formula for Young modulus. Okay. And if you see the graph, আমি যেতিয়া গ্ৰাফটো draw কৰিছিলো in Hooke's law, we have seen that in x-axis we have strain, that is E and E. In y-axis we have, that is stress, normal stress, and our graph is linear up to proportional limit like this. This graph is linear. So if you consider theta here, and if you consider tan theta, if we draw one vertical line here, then what we get? Tan theta is nothing but, if this point is sigma and E, then we can say what is perpendicular? Perpendicular means sigma, and what is base? Base is nothing but E, right? So ultimately, if theta is small, theta to jodi small hoy, tan theta is tan to theta, right? So equal to sigma by E. Aru etu ami sigma by E. So etu ami ki boli paisilo as per Hooke's law, that is E, capital E. That means modulus of elasticity. So if you consider this particular graph, then you can find that modulus of rigidity is nothing but slope of stress strain graph. So that is another important point, that is modulus of rigidity is the slope of stress strain graph. This is one conclusion which is coming out from the Hooke's law. Next, now question arises, what is the unit of modulus of rigidity, right? So if you see from the definition, modulus of rigidity is nothing but E is equal to strain stress divided by strain. So we have know that strain is nothing but change of original length with respect to original length. That means if del L is in meter, if L is in meter, ultimately strain has no unit. Right? So we are left with sigma, that is stress. That means Young modulus or unit to directly stress or unit or equal hobo, and we know that stress is nothing but resistive force divided by area. That is, if we denote resistive force in Newton and if we denote area in meter square, then ultimately the unit of modulus of elasticity is Newton per meter square, which is the SI unit, or we will denote that as a Pascal. So here we can see one particular relationship, that is 1 ampere. 1 ampere mane ki hoi jabo? We know that whenever mega term is come, that means 10 to the power 6. 1 ampere mane kiman? 10 to the power 6 Pascal, right? And we have know that 10 to the power 6 Pascal means what? Newton per meter square. So if you convert Newton per meter square as Newton per mm square, what will get? 10 to the power 6 Newton. If you convert 1 meter as mm, we can write as 1000 mm is nothing but 1 meter. So if we squaring it, so ultimately we will get yet 3 0 ase, while we squaring we'll get another 3 0, right? So 10 to the power 6 0 আমি পাম so আমি ওপৰত পাই যাম 10 to the power 6 তলতো পাই যাম 10 to the power 6 ultimately this will cancel out we'll get Newton per mm square so we get 1 megapascal is equal to 1 Newton per mm square this is widely used unit for determination of stress or you can say Young modulus so this one relationship you have to remember from exam point of view next we'll see about elongation of a prismatic bar so amar jodi eta prismatic bar thake so how that bar is elongate if it is free to expand that means suppose if we taking one bar that means this is my rigid support in one side and another side is free to expand so this side is free to expand so if you putting external load P here what we can see this support is fixed support and this support is free support because of application of this force P if the original length of the bar is L because of application of this tension force the bar will tend to extend suppose this elongation is del L in this side the bar will not extend why because this fixed support provide resistance to the body right so if you try to find the elongation what we can see from the Hooke's law we know that stress is proportional to strain if stress is proportional to strain that means we can write as stress mane external force divided by area yes and if you remove proportionality sign we get modulus of rigidity E or into what we can say strain mane ki change of original dimension with respect to original length change of original length with respect to original length that is del L by L or if you try to find the value of del L what we can get P into L divided by AE that is the important formula for determination of elongation of a prismatic bar mane ki prismatic bar is we can say a bar who is having uniform size and shape there is a uniformity throughout the length because the length is same area is same that means it is a uniform bar okay that is called prismatic bar so that is the elongation so in exam sometimes you are given the value of P you are given the value of external load and also you are giving the area of the bar and modulus of elasticity and you have to find the elongation and that unit will be mm meter that is something length right because length or kotha ami eta sai asilo elongation so that is the elongation of a prismatic bar in similar manner if the bar is not prismatic suppose it is a taper bar if you consider a tapered bar means a bar who is having different cross section suppose this is my tapered bar suppose this is D1 this diameter is D1 and this diameter is suppose you can say D2 so this is nothing but a tapered bar why it is tapered because here see diameter is increased linearly this is not fixed but prismatic bar ki asile equal asile D1 equal to D2 so for calculating this we can use the help of integration ami integration kori ইয়াৰ ফৰ্মুলাটো উলিয়াব পাৰো elongation due to tapered bar elongation due to tapered bar so what we can do আমি অলপ আগতে উলিয়াই থৈছিলো prismatic barৰ কাৰণে কি PL by AE this is the elongation formula but here you can see the area is varying right that means area ta amar changes aise because diameter to change hoise so ultimately integration small m jodi ami eta element lo a bar tur majot suppose the length of that particular small stirrup is nothing but dx আৰু suppose ইয়াৰ diameter to আমি d ধৰিছো and this length is suppose capital L আৰু ইয়াৰ পৰা ইয়ালৈকে distance to suppose x ধৰিছো so what will be the value of d এই d ৰ value to আমি কেনেকৈ লিখিব পাৰো we can write as d1 plus d2 minus d1 since it is a linear divided by what is original length L আৰু কিমান to point লগে গৈছো suppose x point চাই আছো into x since it is a linear increment so see যদি আমাৰ x or value to 0 হলেতেন that means d1 answer হ'ব লাগে এটা সো x or value to যদি 0 পাতি দিও ultimately this term will be 0 ultimately you will get the value d1 similarly যদি x or জায়গাত l পাতি দিও l cancel out হ'ব d1 cancel out হ'ব ultimately ইয়াতে আমি পাম d2 that means this diameter formula is correct right so if we try to integrate with taking small stirrup and we will integrate from 0 to L capital L okay and P suppose ami small stirrup loisu so you can say the length of small stirrup is dx what is the area is nothing but pi by 4 into d square but here our d is nothing but this one d1 plus d2 minus d1 L into x into square and into e so ultimately jetia a integration to kora hoy and the result will be you can get 4pl pi e d1 d2 this is the last formula you can derive from this integration so in this lectures we have seen elongation due to prismatic bar that is del L is equal to PL by AE and we have seen elongation due to tapered bar. So here you can say elongation due to prismatic bar the length is directly proportional to original length elongation is and also it is directly proportional to the loading or the external load and it is inversely proportional to the Young modulus. Similarly here also we have seen it is inversely proportional to Young modulus directly proportional to load and directly proportional to the length of the bus. These two formula we have seen here. So this is the important conclusions or important derivations which are coming from the Hooke's law. I hope apnaloke video to pra upokito hoise. Thank you for watching.